Okay, so now let me start the session. Let me present the screen to you. Sorry for the delay. Because here for sixth semester students also offline classes started. Just completed the session and came. Give me a minute. Yeah. So yeah. So today morning we have discussed about logistic regression and we have done practicals about logistic regression with tc1 students, but tc3 students we are going to do the practical things with logistic regression in tomorrow's laboratory. Okay, so now what we have to discuss is we are going to discuss why we are using this logistic regression and some part of logistic regression we haven't covered in the laboratory, and also it may be tc1 students may get some repetition. Okay, just adjust with that repetition. But anyway, we are going to cover new things actually that I haven't covered in the laboratory. Also I'm going to cover. Okay, now, so yeah, so as we discussed earlier, logistic regression is used for classification. Now we are getting into classification, then prediction. So we have to ask the question, what is the difference between classification and prediction? Okay, so if we get into this question, classification and prediction, mostly with prediction, we are predicting numerical values. Okay, we are predicting numerical values and we are predicting quantitative values. Say for example, how much mark you will score in the examination, and what will be the share value of the particular company next month. What is the price of the home which is having 3 bhk and 2500 square feet in this particular location. Like that, we are always doing this prediction with the help of simple linear regression and multilinear regression. Okay, so simple linear regression, multilinear regression, and polynomial regression, all we have discussed is with respect to numerical prediction. Okay, all we have discussed is with respect to numerical prediction. Okay, so classification is nothing but, see, fundamentally classification is about predicting a label, and regression is about predicting a quantity. Okay, so this is the case. Now my question is it possible to do classification through regression? Is it possible to do classification through regression? Is it possible or not? It is possible or not? Yes. Any answer from your side? Yes. Classification through regression, is it possible? Yes, it is possible. We have discussed in the morning itself, it is possible. Okay, classification through regression is possible, but what is the important thing is we have to go with probabilistic regression model. We have to go with probabilistic regression model. So regression model predicts a continuous variable such as rainfall amount, sunlight intensity, like this. Okay, they, and also few regression models can predict probability values also. Okay, so based on the probability value, we can take it for the classification. Okay, how we are adding this in classification, in the sense, based on the probability value, if probability is less, in the sense class 0, if probability is high, in the sense class 1. Say for example, if we are having two classes, safe customer and unsafe customer, in the sense, if the probability is less, we can put it in unsafe customer. If probability is high, we can put it in safe customer. Okay, so you can fix the threshold as 0.5. Okay, you can fix the threshold as 0.5. If the probability is less than 0.5, you can put that into class 0. If the probability is greater than 5, in the sense, you can put it into class 1. Okay, so you can ask a question like what will be the answer if the probability is 0.49? 0.5 is yes, but 0.49 is no only. Okay, that problem we are always having. Okay, so that's how this is working. Okay, see a probability. See, say for example, a probability predicting regression model can be used as a part of classifier by imposing a decision rule. For example, if the probability is 50% or more, decide it's a cat. Okay, so if you're having a probability, which is less than 50 percentage, in order to decide that as a cat, in the sense, you can, if the probability is more than 50, you can say that as cat. Otherwise you have to put that in a dog category. Okay, in order to classify or in order to categorize dog and cat, so you have to go with this kind of model. Okay, probabilistic model. So based on the probability, you are deciding classes. Okay, based on the probability, you are deciding classes, class A or class B. Actually, that regression model is providing probability. Based on the probability, you are deciding classes. Yes, got my point? Understood? Any doubt as of now? Yes? Yeah, give your acknowledgement through chat. Any doubt as of now? Yes, Arun, Rudvi, Harsh, Komal, Parth. You mean any doubt as of now? The
No, sir.
introduction? Okay, yeah. See, okay. Yeah. Now, so I hope you understand where logistic regression exists. Okay, so logistic regression is a probabilistic model. Here you have to listen carefully how it is working. So logistic regression is a probabilistic regression model. Output of logistic regression is probability. So based on the probability, we can do classification. If probability is high, we can put it in one class. If probability is less, we can put it in another class. Okay, so that's how it is working. Okay, so just look into this. Logistic regression is used when the dependent variable or target variable is categorical. So this is the case. Okay, normally when we were discussing about simple linear regression and multilinear regression, we were using when we were discussing with simple linear regression and multilinear regression, we were using target variable as price. Okay, price is a target variable. So price is not a categorical variable, it is a numerical category. So price is 5,000, 6,000, 10,000, $10, $15, $50,000. Likewise we have decided. So here, categorical variable, in the sense, it is having category like safe and unsafe, spam mail or good mail. Likewise, okay, yes, no. So likewise we are having classes. So whenever you are having response variable or dependent variable as a categorical variable, you have to go with logistic regression. Otherwise you have to go with some other regression mechanisms in order to predict. Okay, so that is not into classification. Okay, so example, yeah, predict whether an email is spam or not. Okay, predict whether an email is spam or not, whether tumor is malignant or not. Okay, finding a tumor, tumor, whether cancer is present or not. In order to find that, okay, we have to decide, okay, 1 or 0. Okay. This should be, decided. Then, see, now just look into this particular, equation. So how this, by looking at this, you can able to understand how this model is working. Okay, so normally this probabilistic model, or the logistic regression, is giving output 0 or 1. Okay, with respect to binary logistic regression. Now we are dealing with binary logistic regression. So it is giving output 0 or 1. Okay, it is giving output 0 or 1. So see, what we have discussed, we are using y equal to mx plus c for simple linear regression, y equal to m1 x1 plus y equal to m1 x1 plus m2 x2 plus m3 x3 plus c. Likewise, we have used a formula for multilinear regression, and for polynomial linear regression, we have used the formula y equal to m1 x1 plus m2 x1 square plus m3 x1 cube plus m4 x1 power 4. Like that we have used. Okay, for here in logistic regression, we have to use the sigmoid function. Okay, in logistic regression, what we are doing, we are using sigmoid function. Okay, logistic regression is based on sigmoid function. So what is sigmoid function? So this is the formula for sigmoid function. S of x equal to 1 by 1 plus e power minus x. So S of x equal to 1 by 1 plus e power minus x. Okay, so this is the formula. This is the formula for the sigmoid function, 1 by 1 plus e power minus x. See, why we are using this particular formula for logistic regression? You may get question, why we are using sigmoid function for a probabilistic regression model. Okay, see, I have answer for that. Yeah, just come to this. I'm getting into your data. Okay, see, put any value for x. Okay, put some value, take an Excel sheet and put any value for x. Okay, -8, -6, -4, -2, 2, 4, 6, 8, 10, 12. Put any value for x. Okay, whatever may be the value. If you apply sigmoid function is nothing but 1 by 1 plus e power minus x. Okay, if you apply sigmoid function on that x value, you will get value between 0 and 1 only. You will get value between 0 and 1 only. It will not go beyond that. Okay, see, can anyone tell, is there any other function which is providing result between 0 and 1? This is the question for you. Other than sigmoid function, okay, other than sigmoid function, is there any other function which produce result between 0 and 1? This is the question for you. Arun Singh is telling Fashi. Okay, what is the function? Fuzzy is okay. What is the function? Tell me. Tell me the function. 1 by 1 plus e power minus x. Can you try with tan x? Tan x, sin x. What will be the range of tan x and sin x? Sorry, tan. Yes. What is the value? Is it working? Tan x, sin x. Whether it will work or not? That is my question. Yes. All real numbers. All real numbers. Okay. Let me check. See. For tan x. Okay. Let me check. Here I have sin x minus 1 to 1. Sin x is minus 1 to 1. Miyank is telling sin x is minus 1 to 1. So we can't go with minus 1 to 1. Yeah. Arun is also telling. So sigmoid function is the only function which is providing 0 to 1. That's why we have taken sigmoid function. So we can take mod of sin x. Okay. Mod of sin x, yeah. It will produce. And also just put a graph for mod of sin x and plot in your machine. Then I will see how the curve is looking like and why that is not suitable for this. Okay, Mayank is telling, okay, mod of sin x from minus 1 to 1. Okay, yeah. See, mod of sin x. So you are having this idea, mod of sin x. So you may get this question, sir, why you are using sigmoid function? Instead of sigmoid function, we can go ahead with mod of sin x. Okay. Mayank, I'm suggesting on to you, like this, you find, see here, see here x value and y is nothing but a sigmoid of x. The same way you calculate mod of sin x and just distribute the data, then we will discuss. Yeah, we have to explore like this, like a scientist, why they have chosen this sigmoid function. So yeah, Mayank is coming up with, sir, if we do sin x and if we take mod, the values lies between 0 and 1 only. Why we are not taking that? Okay. See, now I would like to give one more the detail to you that we have discussed in the laboratory also. See, the curve is like this. Whatever the value you give, the curve is like this. It is crossing 0.5. See here, if you substitute minus infinity to here, it will come 0. If you substitute plus infinity, it will come 1. And if you substitute 0, you will get 0.5. Okay, minus infinity 0, plus infinity 1. And if you substitute 0, you will get 0.1. So, minus infinity to plus infinity, it lies between 0 and 1 only. That is the case. Okay, minus infinity to plus infinity, it will give 0 to 1 only. Actually, 1 is giving, by default, this function is giving value between 0 and 1. Whenever we are giving input, the range minus infinity to plus infinity, another one you have to take mod. You are using that function and we are taking mod. Okay, so comparatively it is best. By nature it is giving this result. Okay, anyway we will discuss. Okay, So that is the case. Now you can able to understand, see where it is crossing, see starting from here and it is crossing 0.5 and it is going. So this is the curve for logistic regression. Okay, so that's how it is there. So if you can calculate this. If you apply minus infinity, you will get 0. If you apply 0, you will get 0.5. E power 0 1, 1 plus 1 2, 1 by 2 0.5. If instead of x, if you are putting plus infinity, you will get 1. So that way it is working. Okay. See, and one more thing is, see, logistic regression is like, say for example, I'm showing something to you. I'm comparing this linear and multilinear regression and logistic regression. Okay, so have a class here. Which cat here. Here you have dog. See, the data distributions are here, and data distributions are here. You have to classify. Let me consider with linear regression. So, if your line is here, if your line is, sorry, see, if your line is here, you can come for a conclusion like it is belongs to cat. If your line is here, you can say this is dog, and here, so consider this as a 0.5 probability, and this is less than that. So wherever you are getting here, so the input which we are giving is like independent variables. So n number of independent variables are given. So based on that, it is predicting classes. Okay, so binary logistic regression is deciding whether it is cat or dog. Okay, so n number of inputs are given. You can give one weight, or you can give n number of independent variable, one variable or n number of independent variables, but finally it will give a probabilistic value. Okay, that value, based on that value, you are predicting classes, whether it is belongs to cat or dog. Okay, so here z goes to infinity, y predicted will become 1. Z goes to negative infinity, y predicted will become 0. Okay, so this is the case what we have discussed here. Okay, minus infinity is 0, plus infinity is 1. So next is important thing, that is type of logistic regression. In the laboratory with tc1 class, what we have discussed is binary logistic regression. Okay, so that is the one and main thing that we have discussed already, the binary logistic regression. Okay, that we have seen, that is the first type of logistic regression, binary logistic regression. Okay, that we have discussed. Okay, so in binary logistic regression, we have only two classes. So one class may be safe or unsafe, that may be safe or unsafe, spam or not spam, or pass fail, anything, but only two. So multinomial logistic regression, another type is multinomial logistic regression. See here, the categorical response has only two possible outcome. In binary logistic regression, the categorical response have only two possible outcomes. Okay, two possible outcomes. Example, spam or not. Okay, whether it is a spam or not. Okay, so another one which we are having is multinomial logistic regression. Yes. Multinomial logistic regression. Three or more categories without ordering. Okay, three or more categories without ordering. Example, predicting which food is preferred more, veg, non-veg, or vegan. I hope everyone know about vegan, right? Yes. Is there any vegan here? Any of you are vegan? Mayank, are you a vegan? Arun? Any of the vegan in your class? No, but I'm seeing in Gujarat all are vegetarians. Vegan, no. Fenil, vegetarian, yes. Vegan, no. Okay. So you are giving answer like logistic regression. Okay, Harsh is also vegetarian. Okay. No, but non-vegetarian. Oh, Arun Singh is non-vegetarian. Arun, are you from Rajkot? Are you from Gujarat or some other state? I'm seeing here, eating non-veg is crime. Okay, roots are from UP. Okay, good. Yeah. Okay. Yes. So vegans are the one, those who are, animals, even milk, they never drink milk, and they never use leather products, and other thing which is coming out from animal. So vegans are that category. So a special group is there in the name vegan, they are following. Yeah. Okay, so you know about vegan, right? But yeah, surprisingly no vegan in our class. Yeah, actually, it is like vegetarian to, sorry, non-vegetarian to vegetarian, and vegetarian to vegan. It's just a civilization. Yeah, we will see how it goes. Okay. Um so predicting with foods, like three categories are there here. So we have to go with, in Western culture, it's very famous. Yeah. Yes. So okay, so yeah, ordinal logistic regression. So another one regression type is ordinal logistic regression. 3 or more categories with ordering. Okay, movie rating. So the categories are between 1 to 5. Okay, the categories are between 1 to 5 we are having. So this is nothing but an ordinal logistic regression, and here we are having decision boundary. Okay, next topic is decision boundary. So here you have to think in a clear way. So where we are keeping our decision boundary. So predict which class data belongs to threshold can set based upon the threshold obtained estimated probability is classified into class. Mostly in logistic regression, the decision boundary is zero point 0.5. Okay. If you ask the question, what about 0.49? Yeah, it is no category only. Okay. If predicted value is greater than zero point 0.1, then classify email as spam, else not spam. Simple logic in logistic regression. Okay. So that's how this value is working. Okay, that's how this decision boundary is working with binary logistic regression. Okay, just look at the web how this ordinal logistic regression and 3 class logistic regression, 4 class logistic regression are performed. Just look at the web and tell me before the class. Okay, so that's how the decision boundary is working. And here we are going to see about cost function. Okay, so cost function is very important thing. Okay, actually, what is the cost function with respect to simple linear regression? Anyone? What is the cost function of simple linear regression? I'm in the need of your answer here. What is the cost function of simple linear regression? Yes, cost function of simple linear regression. This we have discussed. No answers. Not getting any answer. Parth, Rudvi, Harsh, Komal, Mayank, Tumin, Ludwig. What is the cost function of simple linear regression? Not getting any answer. Dipsa, Fenil, Nishan, Parth, Partrai, Riddhi, Ria, Mesh, Sonal, Umesh, Tumin, Sonal, Rudvik, Rudvi, Ria, Riddhi, Parth, Nishant, Nildeep. Not getting answer from any of you. What is the cost function of simple linear regression? Otherwise, tell me. I don't know. I will remember you. Tell me I can't remember otherwise. No idea. Okay. MSC is the cost function, right? MSC. MSC. Mean square error is the cost function. See, I would like to show that slide to you. It's very important. Where it is simple linear regressions cost function. In class 3. Yeah, gradient descent algorithm we have discussed, right? See, mean square error is the cost function. We discussed, na? Based on the MSC only, we are, it is decided. Cost function is MSC. MSC only, actually, how we are plotting based on the, what is that? Yeah, gradient descent algorithm, how we are fixing the appropriate line in the data distribution with minimum MSC. So MSC is the cost function. Based on MSC only, mean square error should be minimum. Based on that only we are doing. And also here you can able to understand. See, we are performing partial derivative on what? We are performing partial derivative on this cost function only, MSC. Okay, that way only we are performing. Okay, so this is how it is working. So here cost function in our logistic regression is this cost of h of x into y actual equal to minus log of, see here y equal to 1 is one class, y equal to 0 is another class. Okay, if y equal to 1 in the sense minus log of, you know, sigmoid of x. Okay, minus log of 1 minus sigmoid of x if y equal to 0. Here see, I will say here I have answer why cost function is different from logistic, different for logistic regression. Why we are using a different cost function for logistic regression? Why different cost function for this simple linear regression? Just look at this slide and have your idea why cost function is different here. Linear regression uses mean square error as its cost function. In this, we are using a different cost function. The reason is it will be non-convex function of parameter. Gradient descent will coverage into global minimum only if the function is convex. See, now we have to understand convex and non-convex. See here, see it is important thing. In this kind of question you will get in interview if you say I know machine learning and the stuffs all. If the interviewer know the machine learning stuffs and gradient descent algorithm and this kind of linear regression, logistic regression and all, you will get this question. See here, this is convex, this is non-convex. See, in this convex, if you go with gradient descent algorithm, you will reach the MSC. You will reach the MSC, right? Sorry, you will reach the global minima. See, just come to this slide. Just come to this slide where it is. Yeah, just come to this slide. See, here MSC is the high with M and B value, and our intention is to reducing the MSC that we have seen in the practical also. MSC is getting reduced and getting reduced, getting reduced, getting reduced. It is reaching global minima. MSC is reaching global minima. After reaching global minima, MSC will get increased. Okay, so you can able to understand this is the minimum point, and you can fix this as global minima, and you can say you can fix that particular points M and B value, and you can fix the line. You can fix the line, right? Okay, this is how the gradient descent algorithm works. But here in non-convex, you know, the curve is like this. See here, this is, if you apply gradient descent algorithm on this non-convex, your global minima stuck up here, but this is not a global minima, this is local minima. This is only a global minima. So you have to go here and you have to come and you have to reach this position. Okay, then only you can able to identify you know, global minima. Okay, so non-convex gradient descent algorithm will not work. Okay, so non-convex, so that's why cost function is different. Okay, see, if y equal to 1 minus term will become 0. So this is the case. Yes, I hope you understand the difference between convex and non-convex? Yes or no? Okay, so I will, if possible, I will try to execute that also. That is not in part of our thing, but anyway, to give better understanding, to differentiate global minima and local minima, I'll try to bring on code. By executing that, I will give better understanding. But based on this, you will get an idea what is the difference between local minima and global minima. Okay, and just look at this logistic regression assumptions. So the first is binary logistic regression requires the dependent variable to be binary. Now we have implemented binary logistic regression only in the morning laboratory. Morning laboratory, we have taken a simple data set. Morning laboratory, what we have done, we have taken a simple data set which is having the age and uh, insurance. Okay, having insurance is represented as 1, not having insurance is represented as 0. Okay, having insurances represented 1 and not having insurances represented as 0, and we have demonstrated that. So like that, we can say binary logistic regression requires the dependent variable to be binary. Okay, dependent variable or response variable to be a binary, like yes insurance, no insurance, safe, not safe, spam, no spam, like that. Okay, so for a binary regression, the factor level, one of the dependent variables should be represented desired outcome. Okay, one is always a desired outcome. Only the meaningful variable should be included. Okay, see, meaningful variable should be included. It is there everywhere in the regression. So while you are doing regression, what you have to consider, say for example, I would like to show something to you. See, the Excel I'm writing. See, you have variable x, x1, x2, x3, x4, x5, x6, x7. So, and you have y. Y is a response variable. Okay. So you are telling this x1, x2, x3, x4 all are influencing y, in the sense you can keep. Say for example, if you are deciding x3 is not relevant to y, in the sense you can remove x3. You can remove x3 as an independent variable. You have all the privilege for that. You can remove both x3 and x4 also, and you can, if you want, you can combine x3 and x4 and x5 also. If you want, you can combine, you can remove, and you can do whatever you want. That is based on your wish. Okay, in order to decide the response variable, or in order to decide the response variable or dependent variable, you can combine, you can remove, and you can do. So here correlation takes a vital role. Already we discussed about correlation. See, say for example, the correlation between x and y is there, in the sense x is dependent on y. Okay, so if there is a correlation between the response variable and independent variable, you have to keep that independent variable. You have to keep that independent variable. You should not ignore that independent variable. Okay, you should not ignore that independent variable. Okay, wait a minute. Yeah. Okay, see, now correlation between x2, say for example, correlation between x3 and y is 0, in the sense, correlation between x3 and y is 0, in the sense you can remove x3. These are all the important things you have to consider. That's why I am giving bigger data sets to you to explore. Okay, so morning also I have given to me, have done. So likewise, I insist everyone to do with bigger data set. Then you can able to understand these things. And here, and one more thing here, we are going to discuss that. Wait, I will show. See here. Yeah. If correlation, you can set correlation threshold also. Say for example, if correlation high, negative correlation or positive correlation, if correlation is high, you can keep independent variables. If correlation is less also, if you want to remove, you can remove. If you are dealing with more attributes in the sense, you can set correlation threshold and you can remove and you can reduce the dimensionality. So that option also you are having. That is up to you. Okay. And one more thing here is, yeah, only the meaningful variable should be included. If there is no correlation or irrelevant data is there, you have to eradicate those data. Okay, you should eradicate those data. That is the main. Okay, so here you have to look into this particular point. It is very highly important point. See, the independent variable should be independent of each other. There is the model should have little or no multicollinearity. What is multicollinearity? This is the question 5. Tell me, you have to answer. What is multicollinearity? Yeah, you must answer for this question. It's very important for you guys. Dealing with projects also, right? Yes, tell me. Palak, Rudvi, Harsh, Komal, Mayank, Sumin. Not getting answer from you guys. Yes? Tell me what is multicollinearity? Anyone? Anyone? Students? Answer my question, please. Yes, I am not getting any answer. Yes, students. Ayuj. Ayuj Astana. Balakrishna, Dipsha. Fenil Harsh, Komal, Mansi. Miyank, you tell what is this terminology? Yes. No answers I am getting in the chat box. High collinearity between two or more x values. Okay, Harsh is telling high collinearity between two or more x values. Oh, okay. Yeah. See actually, yeah. See, good. Thank you. See here. See here. Look at this. Yeah. Look at this. Here we are having x1, x2, x3, x4, x5. Na. So correlation should be there between x and y. Okay, if x1 and x2 are correlated in the sense that is called multicollinearity. So you have to remove and you have to eradicate that. There should be a very minimum or no correlation between x's or among x. if there is a correlation between x1 and x2, in the sense there is no meaning. We have to remove at least one. Okay, correlation should be there between x and y. Okay, if the correlation is there between x's, in the sense, what is the meaning in that? Okay, so you have to eradicate that. Say for example, you know, I would like to take one example here. X1, consider x1 as, yeah, we are considering the price as y, right? Price. So here, number of BHK. Okay, number of BHK we are having. Number of BHK we are having, and apart from that, what we are having, number of BHK, location we are having, then age of building we are having. See, square feet we are having. See here, see here, age of building, there is no correlation between square feet and age of building. Zero correlation. There is no correlation between age of building and location. There is no correlation. But age of building, sorry, square feet and number of BHK. Square feet and number of BHK, we have very minimum correlation. You can say, if the house is this much square feet, you can say this is 2 BHK. If the house is this much square feet, you can say this is 3 BHK. Likewise, you can come for some idea. Okay, give me a minute. Sorry. Okay, so yeah, so there is a less correlation between age of square feet and number of BHK. So this should be avoided. Here it is less correlation, so we can able sometime, if highly correlated, in the sense between x values, we have to avoid that. So this is the thing we have to consider with respect to logistic regression. Then other points we have to discuss is logistic regression requires quite large sample sizes. Because why we are going with large sample sizes, in the sense, we are having only two classes, 1 and 0. So in order to do the class prediction to large extent, or in order to do the class prediction precisely, or in order to do the class prediction accurately, we have to have large sample size. Okay, that is very essential. Okay, so these are all the points with respect to this linear regression. Then we will see the rest of the things now. So in between, I am simply I would like to show one video to you. It is not related to the machine learning, but yeah, it is related to machine learning only. the how the Google is looking the machine learning, how the Google is utilizing the machine learning. Okay. Yeah, let me show this video to you. Google.
Last year at Google I/O, we announced Google AI.
See,
Last year at Google I/O, we announced Google AI.
can you able to get the voice and video? Just reply me back. Okay, okay, good, good. See, it's the Google I/O. Google I/O Meet is the one the Sundar Pichai is presenting about Google's how they're doing and the technology improvement and what are all about their project, everything in front of the their community. Okay, so it's just about this on machine learning, how machine learning is useful.
Last year at Google I/O, we announced Google AI. It's a collection of our teams and efforts to bring the benefits of AI to everyone. And we want this to work globally, so we are opening AI centers around the world. AI is going to impact many, many fields. And I want to give you a couple of examples today. Healthcare is one of the most important fields AI is going to transform. Last year, we announced our work on diabetic retinopathy. It's a leading cause of blindness, and we use deep learning to help doctors diagnose it earlier. And we've been running field trials since then at Aravind and Sankara hospitals in India, and the field trials are going really well. We are bringing expert diagnosis to places where trained doctors are scarce. Turned out, using the same retinal scans, there were things which humans quite didn't know to look for, but our AI systems offered more insights. The same eye scan turns out holds information with which we can predict the 5-year risk of you having an adverse cardiovascular event, heart attack or strokes. But to me, the interesting thing is that more than what doctors could find in these eye scans, machine learning systems offer newer insights. This could be the basis for a new non-invasive way to detect cardiovascular risk. And we are working, we just published the research, and we we are going to be working to bring this to field trials with our partners. Another area where AI can help is actually help doctors predict medical events. Turns out doctors have a lot of difficult decisions to make, and for them, getting advance notice, say 24 to 48 hours before a patient is likely to get very sick, has a tremendous difference in the outcome. And so we put our machine learning systems to work. We've been working with our partners using de-identified medical records. And it turns out if you go and analyze over 100,000 data points per patient, more than any single doctor could analyze, we can actually quantitatively predict the chance of readmission 24 to 48 hours before, earlier than traditional methods. It gives doctors more time to act. We're publishing our paper on this later today, and we're looking forward to partnering with hospitals and medical institutions.
Okay, see, in this, I would like to, yeah, just think about this. Predicted is 59.1 years, actually is 57.6 years. It's almost close, and see, lot of exact prediction. And here it is saying the diagnostic retinopathy. Here only we have to think where we have to think. Yeah, here it is working better than a doctor, because it is given by uh, it is trained by bigger data set that is larger than a doctor, so it will give accuracy than a doctor. So this is the thing. Okay, how they are going. Actually, this question actually I raised in the research community also, but mostly the corporate companies, the research communities, the journals and other things are one part. Another one is the corporate companies like Google and all. They are revealing only 2% or less than 1% or 1%, 2% information only to the outside the world. The rest of the things they're using to make money. Okay, they never reveal. So our research community is far behind. If you take NLP, Google is doing that NLP translation and everything, but in research, NLP is not in that level. If you go to the research paper and if you read the research paper, NLP is not in that level, not in the level of Google Translator. That you have to agree. Okay? Yes or no? Okay, so that is the case which we're having here. Yeah, I would like to show other things too.
Writing's not that easy, but Grammarly can help. This sentence is grammatically correct. people, and we are live streaming this as always to over 400 events in 85 countries. Last year was the 10th year since Google I/O started, and so we moved it closer to home at Shoreline, back where it all began. Seems to have gone well. I checked the Wikipedia entry from last year. There were some mentions of sunburn, so we have plenty of sunscreen all around. It's on us. Use it liberally. It's been a very busy year since last year, no different from my 13 years at Google. That's because we've been focused ever more on our core mission of organizing the world's information, and we're doing it for everyone, and we approach it by applying deep computer science and technical insights to solve problems at scale. That approach has served us very, very well. This is what has allowed us to scale up 7 of our most important products and platforms to over 1 billion monthly active users each. And it's not just the scale at which these products are working. Users engage with them very heavily. YouTube not just has over 1 billion users, but every single day, users watch over 1 billion hours of videos on YouTube. Google Maps, every single day, users navigate over 1 billion kilometers with Google Maps. So the scale is inspiring to see, and there are other products approaching the scale. We launched Google Drive 5 years ago, and today it is over 800 million monthly active users. And every single week, there are over 3 billion objects uploaded to Google Drive. 2 years ago, at Google I/O, we launched Photos as a way to organize users' photos using machine learning. And today, we are over 500 million active users, and every single day, users upload 1.2 billion photos to Google. So the scale of these products are amazing, but they're all still working up their way towards Android, which I'm excited as of this week, we crossed over 2 billion active devices of Android. As you can see, the robot is pretty happy too behind me. So it's a privilege to serve users at this scale. And this is all because of the growth of mobile and smartphones. But computing is evolving again. We spoke last year about this important shift in computing from a mobile-first to an AI-first approach. Mobile made us reimagine every product we were working on. We had to take into account that the user interaction model had fundamentally changed with multi-touch, location, identity, payments, and so on. Similarly, in an AI-first world, we are rethinking all our products and applying machine learning and AI to solve user problems. And we are doing this across every one of our products. So today, if you use Google Search, we rank differently using machine learning. Or if you're using Google Maps, Street View automatically recognizes restaurant signs, street signs using machine learning. Duo with video calling uses machine learning for low bandwidth situations. And Smart Reply in Allo last year had great reception. And so today, we are excited that we are rolling out Smart Reply to over 1 billion users of Gmail. It works really well. Here's a sample email. If you get an email like this, the machine learning systems learn to be conversational, and it can reply, "I'm fine with Saturday," or whatever. So it's really nice to see.
For just $67, you can make as many videos as you want. You never need to pick up a camera or use any fancy editing software.
Just like with every platform shift, how users interact with computing changes. Mobile brought multi-touch. We evolved beyond keyboard and mouse. Similarly, we now have voice and vision as 2 new important modalities for computing. Humans are interacting with computing in more natural and immersive ways. Let's start with voice. We've been using voice as an input across many of our products. That's because computers are getting much better at understanding speech. We've had significant breakthroughs, but the pace even since last year has been pretty amazing to see. Our word error rate continues to improve, even in very noisy environments. This is why, if you speak to Google, to announce support for multiple users in Google Home so that we can recognize up to 6 people in your house and personalize the experience for each and every one. So voice is becoming an important modality in our products. The same thing is happening with vision. Similar to speech, we are seeing great improvements in computer vision. So when you look at a picture like this, we are able to understand the attributes behind the picture. We realize it's your boy in a birthday party. There was cake and family involved and your boy was happy. So we can understand all that better now. And our computer vision systems now, for the task of image recognition, are even better than humans. So it's astounding progress, and we're using it across our products. So if you use the Google Pixel, it has the best-in-class camera, and we do a lot of work with computer vision. You can take a low-light picture like this, which is noisy, and we automatically make it much clearer for you. Or coming very soon, if you take a picture of your daughter at a baseball game, and there's something obstructing it, we can do the hard work, remove the obstruction, and have the picture of what matters to you in front of you. We are clearly at an inflection point with vision, and so today we are announcing a new initiative called Google Lens. Google Lens is a set of vision-based computing capabilities that can understand what you're looking at and help you take action based on that information. We'll ship it first in Google Assistant and Photos, and it'll come to other products. So how does it work? So for example, if you run into something and you want to know what it is, say a flower, you can invoke Google Lens from your assistant, point your phone at it, and we can tell you what flower it is. It's great for someone like me with allergies. Or if you've ever been at a friend's place and you've crawled under a desk just to get the username and password from a Wi-Fi router, you can point your phone at it and we can automatically do the hard work for you. Or if you're walking in a street downtown and you see a set of restaurants across you can point your phone because we know where you are and we have our knowledge graph and we know what you're looking at. We can give you the right information in a meaningful way. As you can see, we are beginning to understand images and videos. All of Google was built because we started understanding text and web pages. So the fact that computers can understand images and videos has profound implications for our core mission.
What is Matrix 24? Free task management, free time tracking, free...
When we started working on search, we wanted to do it at scale. This is why we rethought our computational architecture. We designed our data centers from the ground up, and we put a lot of effort in them. Now that we are evolving for this machine learning and AI world, we are rethinking our computational architecture again. We are building what we think of as AI-first data centers. This is why last year we launched the tensor processing units. They are custom hardware for machine learning. They were about 15 to 30 times faster, 30 to 80 times more power efficient than CPUs and GPUs at that time. We use TPUs across all our products. Every time you do a search, every time you speak to Google. In fact, TPUs are what powered AlphaGo in its historic match against Laserdahl. As you know, machine learning has two components. Training, that is how we build a neural net. Training is very computationally intensive, and inference is what we do at real time, so that when you show it a picture, we recognize whether it's a dog or a cat and so on. Last year's TPU were optimized for inference. Training is computationally very intensive. To give you a sense, each one of our machine translation models takes a training of over 3 billion words for a week on about 100 GPUs. So we've been working hard, and I'm really excited to announce our next generation of TPU. cloud GPUs, which are optimized for both training and inference. What you see behind me is one cloud GPU board. It has 4 chips in it, and each board is capable of 180 trillion floating point operations per second. And we've designed it for our data centers, so you can easily stack them. You can put 64 of these into one big supercomputer. We call these TPU pods, and each pod is capable of 11.5 petaflops. It is an important advance in technical infrastructure for the AI era. The reason we named it Cloud GPU is because we're bringing it through the Google Cloud Platform. So cloud GPUs are coming to Google Compute Engine as of today.
Can anybody speak confidently, even if they're not born talented? Do you really think that?
We want Google Cloud to be the best cloud for machine learning. And so we want to provide our customers with a wide range of hardware, be it CPUs, GPUs, including the great GPUs NVIDIA announced last week, and now cloud GPUs. So this lays the foundation for significant progress.
Yeah. How many of you are having Google as your dream company? Yes? Okay. To me, good. I really appreciate, very good. Yeah, I heartily, wish you to get this Google. So I can say that one of my student is working in Google, right? So actually, the thing is, it is not. You don't think like it is away from you. It is too. It is not for us. It is only for IIT graduates, or it is only for IIM graduates. It's not like that. Actually, in Coimbatore, there is one college, PhD. I don't know how many of you heard about that. From that college, few students worked. Few students are working in Google. Um, that is not a kind of IIT or IIM kind of college, normal engineering college only. So you all have the feasibility. Okay, so try to get in. Yeah, me also, Mayank. Good. Yeah, I convey my hearty wishes to you. Try to get into the company. Actually, other companies like Indian companies and other IT companies, every Harsh also. Good. Good. Actually, in order to reach Google, first you have Google as your dream company. At least then only you can able to reach, and you can work towards that. Um, yeah, it's good to hear these things from you. Okay, how long they're doing, and that's what I'm surprising. If you look into this, what the companies are doing, and what is there in the research community, in the sense there is a huge difference. Okay, they're far behind that, so that should be eradicated. So how, but based on the research community details, you can get into those companies, but they are far away. They're simply using those knowledge to make money, and they're giving services by that. Instead of simply publishing a paper, instead of simply proposing that idea to someone, what this research community and academicians are doing, even including me, what the academicians and research community is doing, finding someone and writing a research paper, publishing it, and discussing somewhere, conducting conference, and that's all. Okay, no company is taking that and implementing that. That percentage is very less. But these companies are doing research, finding something, and implementing that and coming up with that service. That they're giving that service to you, to end customers. They're giving Google what is the Google Home to you, Alexa to you, so you can utilize. And apart from that, you are using all Google product. That is the best thing. But the research community works are simply in papers. They are implementing, and they are making money also, and they are giving service to the society. Google Map, actually, we were studying this shortest path algorithm, this algorithm, then the minimum spanning tree algorithm, cruise curls, all algorithms in data structure, many years before, from many years before we were studying that. Okay, but they've implemented in Google Map, and they're giving that service in your hand. You are utilizing. You're utilizing. No need to ask with anyone. If you're coming to South India, no, you can't communicate with anyone. Say for example, for me, if I'm coming here, if I'm in the city, in the sense, I need to communicate with each and everyone about the route and all. If Google Map is not there, so this is the service to the society, and they're putting their, they're giving the technology in your hand, and it is used for human well-being. Yeah, that is the power of this kind of companies. That's where we have to use this, you know machine learning kind of stuff. Technology should be used to human, even a layman, even it should serve to layman. Okay, all the persons. Okay. Yeah, I would like to get into the slides. So I have given this UCI machine learning repository data to you. Banking institution, I mean Portuguese banking data, marketing campaign, phone call data. Actually, 2 minutes have analyzed that data and have shown some insights. Okay, now it is the time for you. You go ahead with the data and find some more useful insights. Okay, that will be useful for you. See, if you want to use this in this code which I have shared with you, uh, you know they've used this, where it is. Yeah, see, import cborn SNS in order to implement the style of formatting the data. If you're having large data set, if you need to format, in the sense, for that, if you need to import that cborn, in the sense, if you are using Miniconda, go to, if you're using Anaconda, you can download this package using user interface itself. If you're using Miniconda, go to this shell and simply install using this code. Okay, so yeah, just give enter, you will get this particular package. Okay, so I have explained about this metadata also to you. I think if you want, I will explain it again. Yes, this is the data attributes. So age is one, job. So job is categorized into these many categories. One is admin, blue collar, entrepreneur, housemaid, management, retired, self-employed, service student, technician, unemployed, unknown. Then marital, divorced, married, single, unknown. Education is basic, 4 year, 6 year basic, 9 year basic, high school, illiterate, professional course, university degree, unknown. So likewise, it is classified. Then it is see here if you want to, if want to reduce the classification, in the sense you can reduce. See, all you put together and you can put as a school education, all put together, and basic school education you can write. So likewise you can do. If you want, you just what is the Python code to do that, how to do that, everything you have to see. Okay, that's how you need to explore. Okay, here see, has credit in default, yes, no. Okay, so this is having high correlation. Has credit in default, yes, no. Based on this, we can able to decide the target variable. It is having high correlation. And housing loan, yes or no. It is also having high correlation, but I don't know whether it is positive correlation or negative correlation. If you are having a housing loan for 20 years, in the sense you will you can't able to take any of other loan in your lifetime. 20 years of your life, simply a house will consume. It will not allow you even to buy some good things for your happiness. That is the specialty of housing loan. If you put housing loan for 20 years, after 10 years, if you look at the loan, all interest only you paid, the remaining thing, all, principal amount remaining you have to pay. So that is the specialty of house loan. That is my point of view. I don't know about your point of view. So you Gujaratis are good at investment and handling the things. Okay. Yeah. Then give me a minute. Uh, yes. Yeah. That's how it is working. And if we go with yeah, another, in the sense, another attributes, housing loan, yes or no, loan category, yes or no, contact communication type, cellular telephone, month, last contact month of year, day of week. So after all these details, you have to find why. Has client subscribed the term deposit or not? This you have to do. Okay. So any of you have completed this, please share the screen. And also the another one exercise which I have given, wine quality. Wine quality also now you do and show me the output. Where is the wine quality data which I shared with you? Yeah. So this is the wine quality data. See, fixed asset. These are all the attributes. Based on this, you have to find the quality of the wine. This is the exercise for polynomial regression. This you have to perform. Polynomial regression. I think this also you receive. Yeah. Wine quality also I have shared with you. If anyone have completed, share your screen and show the output. Well, let me take attendance. Yeah, before that, any doubt on this logistic regression? Actually, the tc3 we will see in more detail in the laboratory. Okay, theory part we have finished. It is used for binary classification. We will see in the laboratory, tc3 students. Okay. Okay. So what I'm telling Parth, we will see in detail in the laboratory for tc1. Laboratory has been completed. Okay. Yeah, I will consider you, Parth Roy. I'll consider your attendance. Let me take attendance first. Any doubt as of now for you? Yes. Okay. So let me take attendance. I will take tc3 first, then I will go with. Yes, Rushil. Okay. Rushil absent. Arun Singh present. Prapti. Prapti is there. Prapti not there. Ayush. Ayush is not there. Dipsa. Dipsa is
Yes, sir.
there. Okay. Datkan. Ria.
Yes, sir.
Okay. Ria present. Yash. Yash present, I think. Yash is there. Present or absent? Yash. Parth Rai present. Yash is not there. Forum.
Yes, sir.
Okay. Forum. Suraj. Suraj is not there. Suraj. Suraj. Okay. So that's all about TC3. Prapti absent, Datkan absent, Yash absent, Suraj absent. TC1. Yes. Archan. tc1, please answer. Archan, Ayush.
Yes, sir.
Okay. Krishna.
Yes, sir.
Dhairya. Dhairya. Fenil.
Yes, sir.
Okay. Harsh. Harsh present.
Yes, sir. Present.
Okay. Heli. Het. Hetvi. Javin Kumar.
Yes, sir, Jayant Kumar.
Okay. Jinal. Jinal is there or not? Karan. Komal.
Yes, sir.
Okay. Karan absent. Komal present. Krunal. Krunal. Lata. Manali. Manchi. Manchi Kiara.
Yes, sir.
Okay. Mayank Singh. Mayank
Yes, sir, present.
Okay. Meet. Milan. Sonal.
Present, sir.
Okay. Nesh. Nildeep.
Yes, sir. Nildeep.
Okay. Nishant.
Present, sir.
Okay. Palak.
Yes, sir.
Okay. Path Kurani.
Yes, sir.
Okay. Riddhi. Another Riddhi. Present.
Yes, sir.
Okay. Rudvi.
Yes, sir.
Rudvik.
Yes, sir.
Good. Shashi Ranjan. Sheena. Sharin. Tumin present.
Yes, sir.
Umesh.
Yes, sir. Umesh present.
Umesh present. Vikash. Yash Kumar. Yog.
Present, sir.
Okay. Kaval Kumar. Harsh Mehta. Okay. That's all. See you in tomorrow's laboratory and class. Okay. Anything you want to ask with me? That's all right. See you all.